Ladies and gentlemen, to discuss how agentic AI systems are being designed and deployed to support complex high-stakes missions in defense and national security, please welcome Garrett Berntsen, Managing Director at Accenture Federal Services, Patrick Shafto, Program Manager at the Information Innovation Office of DARPA, and Stuart Wagner, Chief AI and Data Officer of the Department of the Navy. The conversation will be moderated by Colin Demarest, reporter at Axios.
What's up, everyone? Hope you all are doing well today. I am Colin Demarest, the author of Axios Future Defense, a weekly newsletter. The newest one just dropped this morning.
Follow.
I have to plug it. Y'all should read it. I'm on stage today with Garrett Berntsen, the managing director at Accenture Federal Services, Pat Shafto, a DARPA program manager inside I2O, and Stuart Wagner, the Navy's CDAO. We're here to talk about agentic AI and what that means for militaries here and abroad. I think we should probably get a baseline first before we jump in. So let's go down the line. What does agentic AI mean in the national security context, and why should people even care for that context?
Sure. Yeah, I can start. So I think probably a practical example is like always helpful for people. If you think about something like booking airfare or a trip, you used to just Google search and it would pull up a list and you'd go to the website and then you'd book your travel and you'd do some research. With LLMs, you could ask in sort of free text, hey, where should I go? And it would give you an idea or whatever about some text. You could read it. Agentic is about autonomous systems making decisions, taking action with like more independence. So the example here to sort of complete it would be, hey, I want to take a trip. I want to go here, there. It does the research. It looks at your photos and says you've already been to these countries. Don't go there again. And then it says, should I book it? And then you just say yes, and it books it. And so that, obviously, that sort of process, if you can apply to a ton of DoD, national security processes, where we have people clicking between computers, we have people who would really just like to sort of automate parts of their workflow, that it could be a huge time saver. And it also can have improvements in the quality of the outputs as well. Yeah.
Pat, your thoughts?
So yeah, building on that in national security context, some examples would be, for example, AI systems that could help autonomously triage on battlefield scenes. So collect information about wounded and maybe perhaps prioritize triage order and things like this. Or in cybersecurity context, thinking about autonomously responding to potential infiltrations, or even just AI agents that spawn other AI agents that react to circumstances. And all of these, I think, are sort of very cutting edge, very important issues going forward in areas that DARPA is especially focused on.
I think Garrett covered a number of use cases. So my view on it is a little bit different. I view this is a longer effort that we've already started to see play out of increasingly automating decision processes and complex processes. And what we're just seeing is a significant advancement since that time. So if you look at like the history of AI applications in DoD and the history of, for example, natural language processing, like we've had n-grams for a long time, which could write sentences. Whether or not they were as good, whether or not they actually added value is of question. But there was already work going on there. We've already had supervised models making predictions in Project Maven, which was actually involved in increasingly automating the targeting process, right? What we're seeing now, I think, is an increasing effectiveness with unstructured data, the use of prompts, stable diffusion, like the pairing of text to images, being able to both generate and go from image to text. Like we're just seeing a general advancement of increasingly automating the use of processes which could be employed across DoD. Excited to talk about some of the opportunities to apply it and some ways in which we're thinking about and looking at applying it. But the ability to trust a machine, increasingly trust a machine, and see higher degrees of accuracy when we trust that machine to do more complex tasks is really exciting.
And so how big of a leap ahead is agentic AI in the private sector, in maybe the research world, and then maybe on the front line or on a ship somewhere.
Yeah, I don't know how you quantify the size of the jump, but I maybe working backwards from how much private sector companies are investing in this. I mean, they are seeing big returns on reducing, candidly, their workforce. They're seeing returns on making things faster and more efficient. And so, I know it's a little chicken or the egg, but if you see this much investment in an area and companies really staking their business model on this, I think that shows a lot of impact. And there are bubbles in the market too, right? Maybe they're misreading the technology and there'll be ups and downs. But I don't think this much investment, would ever show a complete miss of the technology, the impact of it.
On the research side, I think this is just a natural next step, right? With the increasing capabilities of generative AI in producing images and text and computer code, the natural next question is to think of those things as tools and ask, well, what can we have these agents then do with these tools? And so, the advance there then becomes thinking about how far ahead you can have them work and have it be reliable and not nonsense or junk. And so I think it's very natural as a next step, but again, there's this technical challenge of extending the time horizon.
Stuart, your thoughts?
I mean, there's so many different ways in which this has the potential to change the way we fight, learn, and adapt with data. It's just, I think we're just scratching the surface. A few areas that are top of mind. One is increasingly automating policy calibration and the application of policy. So, for example, you could look at the application of security classification policy and representation of policy, updating policy during war, setting limits on policy, consistency of policy. Policy is a big thing we do in government and at the DoD, and so that's all unstructured text. If you view that as data, the application of that is really exciting. I would say other places where we're most excited about this is the ability of humans to interact with machines. How can I like to say, how can I talk to the telemetry, which is automatically collected data? So what if I could, instead of building, what I used to do as an engineer at Microsoft, was I used to build telemetry pipelines for operating systems and for Azure. And we were building all these dashboards to understand the state of the operating system, what's broken, what should we prioritize to fix, what's the performance, what's changing across releases. What if I could just ask that question directly and then have the machine come back with the answer? And so I think a lot of explored use cases have been humans talking to humans or LLMs talking to LLMs, but what about LLMs talking directly to the data? That's really an exciting piece. Dashboards is another place where we've built all these dashboards to produce very specific answers to very specific questions. But if we can generate the dashboard, well, now I don't know, I may not actually need one authoritative dashboard. I can generate it on the fly. Coding, we haven't even gotten to yet. Coding is crazy. The speed by which people are vibe coding today and generating code, the fact that you don't need to have as much experience with code, I do think refining code is going to be really critical. You need an engineer still who knows how to read the code and make sense of it. But we're finding incredible value, I think, in the ability to generate code and then run that code and run actually DevSecOps. I think in the future you'll be able to run that almost end to end and automating it.
Can I add one thing? I think it's actually a very good point in particular. OpenAI, when ChatGPT came out, those LLMs had been around for a year before or more. Some of them, longer than that. But just putting this very simple front end that worked with some really good design around it, people were it just really transformed the way people were able to interact with LLMs. And it's just a much more natural way to work. I chat most of us just chat on our phones all day long. We're texting our friends, our family. It's just language is a very natural way to engage. And so going from this world where, hold on, I got to find the right dashboard on the right thing. There's 1,000 links here. How do I find it? This is a nightmare. Just give me my Word document, which is generally what happens in government. It's just give me my memo. And I've seen that at a lot of agencies. To hold on, I just want to ask some questions of this, of having the data in the right, structured the right way and ready for that. It is changing the experience quite a bit.
So, but it's interesting. So our representation is of those words, right? But imagine if memos, when I was talking about policy, what I mean by this is imagine if the policy was not represented as a series of like unstructured words. Often there's like nuance or there's like all sorts of fuzziness in language. But if there are ways to digitally represent that, right, you actually don't even need to store the unstructured representation. You just store the digital, and then you tell the LLM to produce the representation at any time. And so that's where I think LLMs are really fascinating.
So I want to follow up with you, Stuart, because the military has infamously bad computers and kind of some very old IT.
That's true.
How do you square that with something as cutting edge as Agentic AI, and then how do you work them together when sometimes you can't even open your email?
Yeah, so I want to take your question for a moment and just like clarify something that sometimes bothers me a little bit, which is a lot of people talk about modernizing IT or modernizing software. I don't actually like that. I don't like to think of it in that way. Like buying a new computer does not fix the fact that the software we run has problems or is highly inefficient or may have multiple virus scanners running at the same time, conflicting and causing poor performance. So like buying new is not necessarily the thing that solves our problem. It is actually being able to instrument and understand what actually is causing the problem and then going after it in targeted ways, which may include modernizing that part of the process, just to clarify. The application of Agentic here, so one, I'll share kind of a preview of something we're thinking about at the Department of the Navy. And we haven't done it yet, but we're looking at ways, we're scratching at this right now, which is basically I have, within my DoD environment, I have, you know, CUI information or classified information or highly classified information, et cetera. And like, how do we bridge, as we start to communicate with these LLMs authorized at, you know, these classification levels, how do we allow them to get new data off the internet and integrate that into the workflow? If, for example, I'm interested in learning, you know, about a weapon system and I want to gather information about that, then it's classified. I want to be able to ask the LLM that. But also the latest information about it may also exist on the internet. So there is like a serious challenge of policy here. How do you ensure you don't leak information to the internet? This is like the ability to agentically deep search is one of the critical capabilities that we're needing and working on right now. And going to the internet and being able to traverse between the internet and classified systems, big challenge right now. We're scratching at that and trying to find ways to solve it.
Pat, it looked like you had thoughts on that.
Yeah, I mean, I think the big gap on the research side is between the fact that these AI agents can do some impressive things, but we need them to have high assurance for certain kinds of contexts. And I think there are really interesting potential developments, again, touching on the semantics point and other aspects of trust here. DARPA for a very long time has been working on formal verification of systems, starting from anti-lock breaks through PDF files to computer code. And I think the next steps are, one, a program that I'm running on formal verification of mathematics, sort of the classic example of a trustworthy system. We prove things rigorously. So can we translate it to code and have that be fully assured? And then the next step to language itself. Like, what can we say, what can we offer as guarantees on vibe coding, for example, right? Like, I ask it to do a thing. Is there any assurance that I can give whatsoever? And I think these are great open questions, hard.
Concur. Like, how do you basically, this is one of our big challenges, is how do we put limits on semantic representation to ensure that basically the machine doesn't go off the rails, doesn't start, for example, in the case of classification, how do we ensure it doesn't talk about something specific to the wrong user? These sorts of challenges is a great area of potential collaboration.
And I'll ask this next question as kind of the outsider here. Like, you guys are the smart people. I'm the one holding the questions. I ride the metro. You've recently started seeing ads for Agentic AI. Why now? Is it just, and why are we having this conversation now? Is it just a matter of we finally have the right amount of computing power? Is it public appetite? Is it just people want to sell it? What do you guys think?
I think probably a combination of all of those. I mean, like there are fundamental breakthroughs in the technology in the last 2 years that make this possible. There's also been some standards work in general, like around MCP. This is sort of standard approach for agentic models to talk to each other. So you have a new technology, people are excited, it's new capabilities. You have to have some like storming and norming to evaluate the standards with which they work, and then you have some companies or government develop some use cases where people say, oh wow, like that would really save an unbelievable amount of time. And I think we're seeing a combination of all of those things. Corporate interest, of course, is a thing. People want to sell it. People want to be more profitable and drive revenue. Or in the government standpoint, they want to. They're in budget constraint environment, which some offices are, and they're saying, how do we get more efficient? We have fewer people. We still have to do the same amount of work or more. This is an opportunity to try to help us do that.
Yeah, I already hinted at what I think is happening, right? We already have seen the advances in generative images and text and so forth, and so in some sense, this is the natural next step. I also want to highlight, though, on the research side, there are interesting and open questions about what kinds of tools an agent has access to and what that means for the shape of their intelligence, right? And so, like, we often think about ourselves as being, the canonical example of intelligence, but of course, other animals do all kinds of intelligent things in different ways that are hard to understand. And so I think, a lot of this rubs up against what turn out to be like very deep and old questions about, what does it mean to be adaptable in the world, and what kinds of affordances do you need to be adaptable in particular ways that are desirable? And I think that's very relevant for national security as well.
Stuart, your thoughts?
Yeah, I mean, I think, so the word agentic to me comes off, I stated this kind of at the beginning, a little bit of a buzzword. This is just a march along the process of increasingly automating decisions and processes. The reason I think the buzzword may exist is because increasingly things that appeared to effectively be magic, right? Like these technologies feel like magic. They're not, but to a common user, they are magic. I think that there's a there on that. The thing that I'm most excited about would be to your point, the speed at which we're able to learn and adapt. And I think I have no evidence of this, but my suspicion is we're increasingly seeing this, like in Ukraine, for example. We're seeing like the measure-countermeasure cycle, the speed at which you learn and adapt, where somebody presents a capability and the adversary presents a new capability that adapts to it. It's just shrinking to near zero.
It's like 2 weeks right now is like the common phrase.
No, we're sub 24 hours.
Yeah.
Yeah, I mean, it's really fast. And so, like, that is
you can do that with software, right? That's the only way. I know we've talked about this before. And yes. From that, you have all these implications to how do you authorize software? How do you train your troops and soldiers? And, I served in Afghanistan a couple times, and like we had to have, field service reps, FSRs, for our technology, very far forward deployed with us. If we're in a near peer competition, will we need like a bunch of software developers from some company, like willing to be in combat, because we need software developers, or are we going to have to train them and bring them into the military or civilian service, right? There's options, but there's whole changes to how we work across workforce, how we field combat ready units, how we deploy software. All of that changes when you get to a world where we have to adapt like every 24 hours to new code.
Yeah, so you need to figure out, we need to figure out which tasks and processes we can take more risk on, and which places where we need a human, actually not just on the loop, but in the loop, approving it, and how do we even increasingly automate that part of it?
Yeah.
Yeah?
Yeah, and I can jump in here. One program that I'm running called In the Moment is focused on exactly this kind of question. We often use battlefield triage as an example where you could have a large number of casualties that outstrip your ability to address them with an individual. And so how do you prioritize these kinds of things? And one hard question there is that there's not always going to be a right answer, at least with the information that's available at that moment. And so it's not a standard paradigm of thinking of, is the AI system correct or not? you have to start asking other kinds of questions about alignment, for example. So big tech companies talk about alignment, but really it means don't say bad things. When I'm talking about alignment in this program, it's really about, is it going to make the decisions under uncertainty that are similar enough to me that I can trust it? And I think these are really hard questions that we need to address ahead of time, both on the policy side and thinking through how this is going to increase the pace of our response across different contexts.
I'm glad you brought that up, because I did want to ask just plainly, why should people trust smart machinery, right? It's one thing to talk about it on stage here. It's another to be, if you're the medic and you're running triage or you're getting bombed or something else, why should you trust that decision to turn right versus left?
Yeah, I would say there is definitely a spectrum of tasks from which, like, we should be extremely, extremely careful, right? To, like, how many people need to review whether my trip expense report is accurate, right? Like, it is incredibly manual. We're probably burning like millions of dollars and hours, just like people. As an executive, I had to review people's travel. It's insane.
I waste way too much time on travel plans.
That's insane, right? But also, like, if I get that wrong, also, there are high risk situations where I will say, wait, this is, I got to look at this because it's like too much, right? It's not saying automate the whole thing, but that's like pretty low risk. Yes, when it comes to like targeting and who gets care on the battlefield, that should be tested rigorously, right? There's a paradigm, I guess. There's a sort of difference in those use cases. The last thing I would say, though, is like humans aren't always the best decision makers either, especially in combat, especially tired, especially hungry and scared. They're like often very bad. They make mistakes. They roll trucks, right? They have friendly fire. They make horrible mistakes, a lot, like more than, and we train really, really hard to avoid that, but it does happen all the time. So the answer cannot be, it has to be perfect. The answer has to be, it has to be as good or better than people. And maybe if we're at a volume issue where the risk is so high, it's actually just under certain circumstances, maybe better to not have an exhausted, person making the call. Maybe it makes sense to have a machine. But we have to think about those risks, and it can't just be turn it all on, but it also can't just be don't use it ever.
So what does the landscape look like in 3, 5, 10 years? What do those breakthroughs, or where is it adopted? And then what's a Hail Mary you would like to see or might be possible?
Well, I think on the research side, there are aspects that touch on the issue of trust. So how do we improve AI evaluation being a big one? We currently give it quizzes like we would to a human, but we know there are good reasons to believe that that's probably not a very good idea, not a very strong indicator, because what we care about is not the quiz itself, but how it behaves in the world. And that question is a question of generalization. And these generalization in these models can be quite complicated. So thinking of mathematical foundations there is one big area that is another program that I'm working on called AIQ. And on the other side, I'll reiterate the emphasis on getting to some kind of foundation that allows us to prove what we can and cannot do, at least under some circumstances. And we're using math as a test case because it is in some sense the closest example of a natural language that is already a formal verification system. But we need to be moving toward things like natural language full stop, because that's how they're being used. And so if we want to be able to trust them, we need to know where are the boundaries. Can we draw any boundaries at all?
For operational systems, I think what we're going to see is just way faster cycle times to fix things and improve things. And so, from a alerting standpoint today, it's like you might see people, if it's for a commercial system, a bunch of people go on Twitter and start complaining, right, about a software update that broke their system, and then it's days or weeks or months to prepare that. I think in the future it's going to be like, you don't even see the stuff hitting Twitter. You're going to see it in your telemetry. There's not going to be a human querying for that. The machines will catch it automatically. You're going to have identification of what to fix automatically and recommended. You're going to have changes proposed automatically. and then you're going to have approvals that test it, that go through testing and V&V, verification and validation, increasingly automated, and somebody's going to make the call to push the button and fix it in and out, the whole process. And so operational systems, like if you are not part of that fixing loop and adaptation loop, if your system is not part of that, like in the case of Ukraine, your drone falls out of the sky.
Yeah.
So then what does, in this far future, right, like what does the role of the human become? And then how does that reshape how the military plans, fights, and then assesses something like a BDA? And then the next step on that question, I guess, and these are a lot of questions, so I apologize, but what does that mean for training, recruiting, and kind of that workforce, civilian or uniformed, that then joins the services?
I guess so I'll answer your first question, like what is the role of the human? I'm not a big believer that we're going to like out-automate, especially in government and defense, national security, like automate our workforce out of their jobs. Like there's an unbelievable amount of work to do in government. People are already overloaded, and if they just like didn't have to do expense reports for like 3 hours, a week, that would be incredible. And half the time, I guess that's very specific to business systems. Yeah. So we'll kind of maybe talk about them both separately. Business systems need a revamp like big time. I don't think anyone disagrees with that. And if people had budget systems that worked and expensing systems and HR systems that functioned and were a lot more automated, I don't think very few people are going to complain. Like they're just going to be really happy that is better. So I think a world where those business systems function and are fast and cheaper should be what we shoot for in like 5 years. I think on mission systems, the big question is like, how far can we get on autonomy? Like truly, how far can we get? And that's a big open question that also has ethical, right, sort of, and legal. There's a whole lot of work around it, policy, technology, hardware, software, all of that. But how far can we get towards autonomy for specific weapon systems will be the big kind of question, I think, in the next 5 years.
I think 2 points to that. Part of the question is determinism and non-determinism, which actually hasn't come up yet. Deterministic algorithms take in the same input and provide the same output every time. Non-deterministic algorithms, they take in the same input, they may provide a different output. Humans are non-deterministic. If you ask somebody how they're doing today, they may answer differently, right? When you have non-deterministic algorithms making decisions, it becomes difficult to trust them, which is, I think, what we're seeing with LLMs right now.
That's why it's hard to trust humans.
That's right, and there's going to need to be some more tolerance or expectation of that. And then the second piece is instrumentation of this process. So a decision-making process, if you ask an LLM why it made a decision, it's actually not going to tell you why it made a decision. It's going to actually predict the next word, okay, like what it should tell you, and what it was trained on. So the instrumentation into this in the next 3 to 5 years hopefully gets better, so we can actually start to answer the question, why did it make a decision in the moment? How did it interpret input?
There was a recent War on the Rocks article by Berntsen and a few other authors who argued that the world is entering the era of agentic warfare. Do you think we're already there, or is it on the horizon? Whoever wants to bite.
I've had to go first, like every tough question.
I guess I have to take this one
first.
first.
Got stuck sitting next to me.
I know.
Where are we on that? I think we're just starting to enter it. So, let's see if you can establish some measures for this. One might be the percent of systems, of operational systems, fielded by any country in the world that operates agentically. The number of that is small. It's not zero, but it's small.
It was a small circle.
It's small. The percentage is small. And so if that's your measurement today, it's small. If we're measuring systems today that are actually being used in warfare, so if you cut it down to those that are going to war, the percent is extremely high relative to that measure. And so I think we're undergoing a transformation right now, and it's just starting.
Last question, and I'd like to go down the line. 45 seconds, lightning round.
Lightning.
Why should people buy into the hype?
I think the proof is in the pudding. People are investing in it. Use cases external to government are showing that it is hugely efficient and can drive down costs and can deliver performance.
Pat.
I would say don't buy it, learn it. Go engage with these systems. They're really impressive in some ways. It's not hard to imagine a world that's changing, but there are also limitations, and research is moving. Be on top of it. Be part of the change.
Yeah. Stu, you get the last word.
All right. I like his answer to just try it, but I'll give one more, which is the risk now is too high to not. Even if it turns out not to be as effective as this panel seems to think it is, if you don't do it, you'll get left. You could potentially become left behind. And what this is showing, like there was this concept of like a 10x engineer. Humans, any human, regardless of skill, is basically with AI becoming 10x more effective in some cases. And so not doing it is very risky for the future.
Fantastic. We're going to have to leave it there. Thank you guys for your insights. Thank you guys for tuning in, and we'll catch you all next time.